Rectangular and polar forms. Rectangular coordinates are your basic XY coordinates, where your vertical distance equals y, whatever your y coordinate is, and your horizontal distance is whatever your x coordinate is. So that's what we're used to. We always know what the rectangular coordinates are. Now we're going to learn about polar coordinates, because that will help us with vectors in the near future. Now, polar coordinates are in a form relating radius of a circle and the angle from horizontal, and it is always written as r comma theta, theta being the angle measure. Okay, so key things to remember here is that r is the distance from the origin, and theta is the angle that is relative to the zero axis. And that is how we are going to describe this point. Okay, now we want to understand how to convert from one form to the other. So converting from polar to rectangular, we are starting with our r comma theta. We know those two parts. And we want to go to an x, y, to our rectangular coordinates. So our x is going to equal r cosine of theta, and our y is going to equal r sine of theta. And then those would be our rectangular points. You will likely get a rounded estimate answer in this case. Now, if we are converting from rectangular to polar, it's a little bit different. We start with our x, y points, our rectangular point. And we want to go to our r theta, so our radius and our theta. So the r, or our radius from the origin, is going to equal the square root of x squared plus y squared, which is essentially just the distance from the origin to our point. And theta is going to equal the inverse tangent of y over x. So let's work through a few examples here. We want to convert to the other form. We are given polar form of 3, the radius of 3 and 10 degrees. So r is 3 and theta is 10. So we want to now convert to our xy coordinates. So we know that x equals my radius times cosine of theta, and y equals my radius times sine of theta. So now I just need to plug in what I know. So that would be x equals 3 cosine of 10 degrees, and y equals 3 times the sine of 10 degrees. If you remember, in many cases, this is going to be a decimal answer, so that's probably what we're going to get here. So we're looking at our x equals 3 times cosine of 10. So if you type in cosine of 10 degrees into the calculator, you're going to get roughly 0.98. So our x is going to equal 3 times 0.98, which is about 2.94. So that is my x coordinate, roughly. And my y coordinate is going to be equal to 3 times my sine of 10 degrees, which is going to give me about 0.17. So y is approximately equal to 0.51. So our exact answer would be 3 cosine of 10 degrees. That would be our exact answer, comma, 3 sine of 10 degrees. And our approximated answer would be 2.94, comma, 0.51. So for now, the approximated answer will be fine. In this next one, we have a rectangular form of 3, 7. So we want to convert that to a polar form. So the first thing we want to do is indicate this is our x and this is our y. So now we have to find our radius, which is x squared plus y squared, and our theta, which is the inverse tangent of y over x. So now if we plug in what we know that r equals the square root of 3 squared plus 7 squared, and theta equals the inverse tangent of y over x, which my y is 7 and my x is 3. So now if I do some calculations into the calculator, I get my radius equals the square root of 9 plus 49, or my radius equals the square root of 58, which is approximately equal to 7.61. And if we come over to the theta is approximately equal to, if you type into your calculator the inverse tangent of 7 over 3, you would get about approximately 66.77 degrees. Now for this to work, you want to make sure that your calculator is set in degrees, not radians. Okay, so our final answer would be approximately 7.61 for our radius and 66.77 degrees for our theta. And again, approximations are good enough for now. So again, in this next one, we want to convert our rectangular form of 2, 5 to our polar form. So we recall that x is our 2 and y is our 5, and then we can find our radius by taking the square root of x squared plus y squared. So my radius is going to be equal to 2 squared plus 5 squared, or 4 plus 25, which is the square root of 29, which is approximately equal to 5.38. Okay, so that would be our approximation for our r coordinate. Now we want to find our theta. Theta is equal to the inverse tangent of y over x. So that would be the inverse tangent of 5 over 2. So 5 over 2 is 2.5. So I'm going to take the inverse tangent of 2.5, which is going to give me theta equals approximately 68.19 degrees. And again, make sure your calculator is set in degrees and not radians. So that makes our final answer approximately 5.38, 68.19 degrees. So our r is 5.38 and our theta is 68.19 degrees. And our last example here, we have the polar form of 475 degrees. So that means that our r is the 4 and our theta is the 75 degrees. So I need to convert to x, y, x being r times the cosine of theta, and y being r times the sine of theta. So if I find my x, that would be x equals 4 times the cosine of 75 degrees. So that would be your exact answer. Or we could estimate, as x is approximately equal to 4 times the cosine of 75, which is going to give us approximately 0.26. Okay, and then what we want to do is multiply those together. And we get x is approximately equal to 1.04. And now we need to go and find our y. So y is equal to 4 times the sine of 75 degrees. So that would be y is approximately equal to 4 times 0.97. And then if we multiply there, we see that y is approximately equal to 3.88. So when we put those together, our approximation for our rectangular form would be 1.04, 3.88. And that would be your final answer. Those are your notes over rectangular and polar forms. You should go through the practice problems and be able to convert back and forth and understand the relationship between your x's and your y's and your radius, and your x's and your y's and your angle measure, because this is going to be very important when we move on to vectors. So go through the practice problems, and then you can take a quiz over this material.